Introducing the Tower of Hanoi.
The Tower of Hanoi is a classic puzzle involving 3 rods and a number of discs of different sizes. The challenge is to move all the discs from one rod to another, following 2 rules. Only one disc may be moved at a time, and a larger disc can never be placed on top of a smaller one.
Why is the Tower of Hanoi important?
The Tower of Hanoi is more than just a game. It's a classic example in computer science for teaching problem-solving and algorithm design. Its structure naturally demonstrates the power and elegance of recursion, a fundamental concept in programming.
Understanding recursion.
Recursion is when a function calls itself in order to solve smaller instances of the same problem. It can be especially useful for tasks that are defined in terms of similar subtasks, such as splitting the Tower of Hanoi puzzle into simpler steps.
Recursive solution explained.
To solve the Tower of Hanoi with recursion, think of moving n disks as 3 steps. Move the top n-1 disks to an auxiliary rod, move the largest disk to the destination rod, and finally move the n-1 disks from the auxiliary rod to the destination rod. The process repeats for each smaller stack.
Coding the Tower of Hanoi.
In code, the Tower of Hanoi is often solved using a recursive function with parameters for the number of disks and names of the rods. The function repeatedly calls itself, breaking the puzzle into smaller steps until just one disk remains, which can be moved directly.
Why recursion makes it simple?
Recursion simplifies the complex Tower of Hanoi puzzle by breaking it into manageable tasks. Each function call handles a smaller problem, making the logic clear and concise. This approach not only solves the puzzle efficiently, but also builds understanding of recursion for other programming problems.